method of transferring data from the input output device to memory is that direct DMA interface. This is most efficient way, because we'll explain how does it happen. DMA, direct memory access. What does it mean? Using DMA interface, the input output device can directly transfer data through to the memory and avoids the processor intervention in this process, so that in this way the processor time is not wasting, because in earlier cases processor has to intervene till the data transfers. Okay, so how does it works? So first, whenever a processor want to read the data to the input output device, what will it do? It will place the device address and control bus to the DMA interface. Okay, device address first, which particular device processor want to read. Okay, and issue the read command. It will issue the read command to the DMA interface. Okay, and also it will give the which memory address it want to store. After reading this data, which memory location it want to store, it will also issue that. Okay, first it will give the device address and read command it will issue. Okay, what then it will do? Because the DMA interface has already got some work now from the processor to read the input data. So what will the DMA interface do? It will set it is busy, because it is busy to read the data from the input output device. Okay, so what will happen next after that? So after that, what will happen? It will read the data from the input output device and data ready flip-flop will be set. Okay, after reading the data from the input. So what will now DMA interface will do? It will interrupt the process. After ready flip-flop is set, after that data is ready in the DMA data register, it will interrupt the processor. See here, you have to see that what the processor will do. Processor will place the device address and read command, because read command, it's just the processor what will do initially, it will place the device address and read command, and it will continue executing its instructions. Okay, it will do its own process, it doesn't bother what happens here. Okay, so it just plays the read command and address. Okay, after that what will happen? DMA interface will read the data from there and it will place in the data register. After that, after placing the data, then only the processor will be interrupted by the DMA interface. Okay, still then what will do? Processor will continue executing its own instructions. Okay, it will keep on instruction. So after interrupted, processor what will do? After receiving the interrupted, processor will do, it will continue complete the execution of the current instruction. Okay, DMA will read the input output device. So then interrupt signal will send to the, after ready flip-flop is set, interrupt signal is sent to the processor. Processor what will do? Processor will complete the execution of the whatever current instruction it is executing. It will complete the execution of the current instruction, and it will give the one memory cycle to the DMA interface. One memory cycle means, what does it mean? Processor will keep on reading between memory and processor. There will be keep on lot of transfers while executing the instructions. Okay, so what will happen? One memory cycle means one memory cycle. One memory cycle means the time required to read or write from the memory to the processor. That means one memory cycle is nothing but number of cycles. Because in a single cycle we can't read from the memory, because it has to place the memory address bus, data bus, it has to issue, and more memory is slower device. So maybe approximately take 10 cycles it will take to one memory cycle. 10 processor cycles. Memory cycle is nothing but memory cycle and processor cycle is different. Okay, processor cycle is that just like clock period of the processor. Memory cycle is that number of clock periods, number of time period, number of clocks it will take to complete one memory processor, because it is 10 times slower. 10 times slower means 10 clock periods it will take approximately. Okay, you understand the difference between memory cycle and processor cycle. You have to understand. Memory cycle is that the time required to read to and fro between, read from the memory or write to the memory. Okay. Processor cycle is just as the clock period of the processor. It is much faster than the memory cycle. Okay. You got it clear? Okay. So what will the processor will do after receiving the DMA interface will interrupt the processor. Okay. After interrupting the processor, what will the processor will do? It will complete the execution of the whatever it is executing currently. It will complete it and hand over this bus to the DMA interface. Okay. What does it mean for one memory cycle? One memory cycle means required to transfer one cycle of data from this register to the memory. Okay. The number of cycles it requires. Okay. Then after completion of this requires, again it is okay. Then also it will give the address, which location it has to store in the memory. Processor will also give the address. Okay. Address and will yield this cycle. This cycle means it stop using this bus for. The processor will stop using this bus for how much time? One memory cycle. One memory cycle is nothing but that time required to transfer from DMA to the memory. Okay. After completion of this, again the processor resumes, keep on continuing execution. Okay. This is for single data transfer. Okay. Single data register transfer. If there are multiple, for example, 100 bytes has to be transferred from the input output device to memory. What will the processor will do? There will be a count. There will be a counter in the DMA interface. Okay. Every time it reads the single data, and when the data is ready, every time it reads 1 byte and the data will be ready in the data register, and the ready flip-flop will set and the processor will be interrupted. Okay. The processor will complete the current instruction execution. It will give one memory cycle again. Immediately after one memory cycle, it will within that one memory cycle it will transfer the data. Okay. And again the count is reduced. This process repeats again and again till the entire data is transferred. Here you have to remember that input output device is much slower. Okay. For example, 100 times slower. For example, roughly 100 cycles, 100 memory cycles. What does it mean? 100 memory cycles means roughly means what does it mean? Just it will out of 100 times because if there is a transfer of data 100 times between memory and processor, in between only one time the DMA interface will require the data transfer, because that means processor will transfer 99 times and it will give one time to the DMA because it is very slow. Because processor runs much faster, it can transfer 99 times while executing its instructions. In between only one time it will give to the DMA register because its speed is very slow, it's only request. So this 99 time cycles, the processor time is not wasting. Okay, you understand? So what will happen? So in burst, some input output devices are very faster. Okay, normally input output device is slower, but some input output devices are very fast. Okay, in that time what will happen? The processor will, instead of for every single byte it is interrupted, every single byte it transfer, instead of giving, it will suspend the bus for continuously to transfer all the data, because input output device is also faster. Okay, that mode is called burst mode. Burst mode means it continuously transfer, not intermediately. It continuously transfer from input output device to memory. At that time input output device is faster device. Okay, you have to remember that is a fast device. So this process is very much efficient because it's not wasting the processor time. Only thing required is extra hardware. Okay, so cycle stealing is nothing but memory cycle stealing. That means whenever the data is ready in the DMA interface, what will do? It will interrupt the processor. So processor, what will happen? It will stop using the memory bus and these buses. Then at that time this DMA interface will transfer via using this bus. Okay, so cycle stealing is nothing but the suspension of these buses by the processor. So when the processor suspends, this same bus can be used by this DMA interface to transfer. So instead, this cycle stealing is nothing but processor is not using the memory bus at that particular time of one memory cycle. Memory cycle is nothing but time required to transfer data to memory to processor or DMA to processor. Okay, DMA to memory. Okay, So cycle stealing is nothing but the processor is sacrificing one memory cycle to the DMA control so that it can directly transfer. So there is one more logic actually. See here, instead of having the process sharing the bus, why don't we should not have two independent buses? Two independent buses means like this. This is a separate two bus to the memory. Why should not we have? Because there is only one reason is cost. Reading to connecting like this will be costly affair. Okay. And one more thing is that sharing is that this input output device is much slower. Memory processor is much faster. Input output device will use the bus transfer. This bus will activate rarely. Rarely means roughly and one time out of 100 processor memory cycles. That means one time it is using, 99 time processor is using. At that time having a dedicated bus to the DMA interface is very inefficient. You understand? That's why shared bus will be used. Whenever DMA interface is required the bus, the processor will suspend the bus for that particular memory cycle. It stop using the DMA interface will transfer and it sets the flip-flop again. It is normal ready. So again it will transfer the data. Okay, the processor continues using. Here the simple logic is that the processor time is not wasted in waiting for the instruction to be executed. Okay, you see again actually. So here what will happen that processor will give the address and the device address. Once the data is ready flip-flop will be set and an interrupt will be given to the processor. The processor will complete the execution of the current instruction and hand over the bus to the DMA interface for one memory cycle. That is called cycle stealing. Cycle stealing is nothing but processor handing over the memory bus and address bus to the DMA interface. So within that one memory cycle it will transfer the data. Okay, that's why the DMA transfer will happen. Similarly to write operation also, it will give the address of where you should write. It will read the intermediately, it will steal the cycles and it will write the particular input output devices. This way the DMA interface will work. It is more efficient than any other method of input output transfer. Only thing is that extra transfer. You should not confuse with cycle stealing. Cycle stealing is nothing but stealing of something, not stealing of something. It is just processor will continuously use this input output memory and processor communication. Okay, intermediately when the data is ready in the DMA interface, it stops using this bus for one memory cycle. That is nothing but stop usage is called cycle stealing. Okay, at that time while it is not using this bus, the same bus will be used by the DMA interface to transfer data from the DMA interface to memory. Okay, that cycle is called cycle stealing. Okay, in burst mode it continuously suspend so that when the input output device is faster, it will continuously transfer. That is the burst mode. Okay, thank you.